All right, so I'll be sharing my screen now. I don't know, once my screen is visible, please let me know. So where do we stop last time? I remember we were like, okay. So I think the last thing we looked at was move, right? The concept of ownership, having a single owner, and then we illustrated it. So I don't know if anybody still have like a question, maybe any question from ownership before we move on to the next one, because the next thing we'll be doing is dependent on this. So all right, so okay, yeah, so I think this is it. All right, so anything? All right, so now we'll continue from here. The last thing we looked at was the concept of ownership, right? Where I explain how Rust manages memory, where at every point in time you can only have one owner for any sort of variable you are declaring. That variable will have just a single owner, and then if you are taking the value of that variable and you are giving it to another variable, what you'll be doing is you'll be moving that value to the new variable. Why? Because at every point in time in Rust you can only have one owner, right? So what it means is that you are moving the ownership from variable. So let's say for instance we have, so let's do fm main, right? So let's say we say let v1, that's variable 1, let's say let it be Rust. So I don't know if it's big enough. Okay, then and then come here and then say let me even print this variable 1. Let me be sure that that's what it is, right? So if I print this one out, why is this thing under? I would have loved it to be by the side. Oh, how did I do it the other day, Seth? I know that it was by the side. So how did I do it?
Is it the same tool?
Yeah, it is. Okay, it's not. Thank you.
It's programmizer. I think is what it is.
Yes, you are right. Yeah, you are right. You are right. I was afraid though. I prefer this one that is
Programming.
running side by side. Yes. So good. So let's say we have let v1 be equal to, let's say, Rust, right? And then we'll now say, okay, we want to now print this v1. Let's see what v1 is, right? Right, so v1, and then on running this, of course we have Rust, we have it printed. So but let's say for instance, let's check, okay, now we want to create a second variable, but we want this second variable to have the same value with this first variable. So if we decide that, okay, since already we want v2 to also be Rust, but already v1 is rust, we can come and say okay oh, let v2 be equal to v1. Now unlike other programming languages like python, like c programming, like javascript and the rest, right? Once you do this, you find out that it means that our v2 will now be rust also. So if we print v2, v2, right? If we print it out, we now see that v2 is now also rust. But what has happened here is that v1 has been moved. That is, at this stage where we are making v2 v1 the value of v2, we have as well moved the ownership of v1. So v1 no longer owns this value, and because it no longer owns this value, v1 is no longer valid. So in this case, if you mistakenly come and say you want to print v1 out, right? Let's say we want to print v1, and you run it, you see what rust is going to tell you. No be juju be this. Is this rust that we are writing abi is another language?
So I think there's an error here because I don't think it's supposed to work.
Yes, my brother, like I'm surprised, me too. Yay. Okay, so can anybody cite anything? Wow. It's even executed successfully. Okay, let me check something. I think I know why. Yeah, I will explain why it worked actually. Yeah, good. So I will explain why it worked. So you can see here, I guess that day what I did was that I used string from. Yeah, so I will explain why it worked. Sorry, it's a mistake from my own end. So now you can see here it's telling you that borrow of moved value. So all this one is just story. The main idea here is that value moved here. So you can see that's why I put this comment here, so that we'll know that okay, at this point, this particular place, the ownership has been moved from v1 to v2. So after this line 7, v1 will no longer be valid. So you can see it, they are even telling you here that instead of moving the value, you can just clone the value. And how do you clone the value? You just use dot. Instead of just v1, you add dot clone to it. So in this case, you find out that our code is going to work. Why? Because at this staging point, what you are doing is that you are cloning the value. You are creating an entire, what is happening here is that you are creating another v1 in memory, like a new v1 in memory. That's what is happening here. So it means that you are having two v1, this main v1 and this v1 that has been given as v2. So but always take note of clone is memory intensive, so avoid using clone in your code as much as possible. That's why the fact there are some instances where it's unavoidable. That's why you can see even here they told you that consider cloning the value if the performance cost is acceptable. Using clone has a performance cost. So always take note of that. Good. So that is rust uh ownership model. You can only have one owner at any point in time. All right, so is somebody raising up their hand? Okay, Obed, go on.
Okay, sir. Good evening, sir.
Good evening, how are you?
I'm fine, sir. How are you, sir?
I'm fine, thank you.
Okay, sir. My question here is
Yes,
borrowing is
yes.
memory borrowing. The borrowing memory intensive also.
No, it's not at all.
Okay.
Yes,
Okay, well, can you kind of explain a little bit about borrowing? Like,
yes, actually that's
yeah.
where we are. So I just wanted to start here so that we'll get the concept of where borrowing is coming from.
Okay, okay, sir. Okay, sir.
Yeah. So you, if you remember, there was something I first did where I was like, it's not supposed to run, and it ran, right?
Yes, sir.
So we'll look at that too. So I guess using this editor is good, but it will do us more good if we use our VS code, right? So sorry. So let me, I'm coming. God, sometimes I just used to be confused of where to enter. So uh-huh. So it's better we use this so that we'll be seeing the data type alongside what we are doing. I think that way is going to do us more good. That, so let me see. Good. So let's go to our,
I think Christiana is raising up.
okay, Christiana, how are you?
Hi, sir. Good evening.
Good evening.
Yes, good evening, everybody. So I just concerning this ownership, like
Yes.
I don't know if can you make a reward like a reward example?
Okay.
Because yes, I still don't. I know it's ownership, but can you like a reward example? Maybe
Okay, maybe it will
I
stick.
don't know if you can understand. Yes,
All right. So, Christiana,
yes, sir.
you have a hair, right? A, what did they used to call that hair? That lady's hair. I've forgotten.
Is it bone straight?
You have a bone straight, right?
Yes, sir.
And then let's say I want to attend, let's say Jethro is getting married and I want to attend Jethro's wedding. And I'm a lady. I'm just assuming in this case I'm a lady. Yeah. Right? So
Yes, sir.
so I now come to you and say, Christian Alpha, I saw one bone straight that you used last week. Oh, and I want to grace Jethro's occasion. And I have to look very nice. Maybe, probably, who knows, I might see my future husband in the occasion. Right? So
Yes, sir.
uh-huh so I now come to you and say, okay, please borrow me your bone straight. Now you borrowed me your bone straight, right?
Yes.
Good. But has it become my own? For the fact that you gave me, has it become my own?
No.
So you find out that in this case you are the only owner of that bone straight. That your particular bone straight, that particular one, is for you. You are the owner. So me, I can come and borrow it. Probably you have other friends too, that maybe you are very close to them, that they too can come and borrow it from you. But at the end of everything, once we are done using it, we know in our mind that this thing is not for us, it's for Christiana. So we still have to give her back. You understand?
Yes, yes, yes.
So now you are the only owner. Now you can decide to say, uh this Gideon, he has been trying. Oh, he has been trying. Since I'm getting another bone straight tomorrow, why not let me just dash him this one? So you will now be like, okay, Gideon, you know what, don't return the bone straight, I dash you. So in this case now, what you have done is that you have moved the ownership from you to me. So the bone straight is no longer your own property, is now my own property.
Okay.
Yeah.
Okay.
So
Yes,
that
sir.
is the model that Rust is making use of.
Yes,
Every
so.
single variable, every single value has an owner.
Oh,
You understand? And the owner
yes.
can only be one owner.
Okay.
So if any other variable wants to use the value of that one, he has to either, number one, borrow it, and that's where references comes in, or he gets it from the owner, like he collects the ownership from the original owner.
Oh, okay. I understand now. I
Aha.
understand, sir. Yes, I understand.
Aha.
Yes,
So
sir. Thank
you're welcome.
you.
So let's look at borrowing and references, right? So now it says references let you access data without taking ownership. So just like your reward case, right? I think I made an illustration with car last week. The last class we had, right? Where I say I can borrow, probably, let's say, like Obed has a car. I can decide to say, okay, Obed, me, I want to go to maybe somewhere. So please, can you borrow me your car and all of that? I think I use Jethro and Obed, right? And me. Where I say, okay, let's say Jethro um has a car, or sorry, Fitech has a car, and then Obed wants to go to Jetro's place in Jos. Now, Obed can be like, okay, Fitech, can I please borrow your car? And then Fitech will be like, okay, no problem. You are one of our members. There's no issue. So far, you fuel it. So, and then Obed takes that car and drives it to Jos. And probably when Obed got to Jos, he now find out that he has to stay like for a week or more. And he knows that Fitech might likely need their car in 2 days' time. And then maybe like me now, I'm in Jos and I'm coming back the next day, right? Obed can be like, okay, Gideon, there's a car here, but it's not for me. I feel you can use the car, but it's for Fitech. So probably you can take permission from Fitech. So it means Obed borrowed the car from Fitech. He was supposed to return it, but because he's not coming back quick, he needs somebody to take it back to Kaduna for Fitech. So in that case, since me I'm going to Kaduna, I will now borrow it from Fitech. Borrowing it from Fitech because Fitech is actually the owner. I'll collect it from Obed and then drive it back to Kaduna and return it back to Fitech. So that is how borrowing and references also works in Rust. So you say references let you access data without taking ownership. So the value still belongs to the variable, but now you are borrowing the value from the variable. It's like you are telling the variable, please give me this your value. I want to make use of it. Once I'm done, I will return it back to you because I know that yes, you are the original owner, right? So now, just like how we are talking about mutable variables, we also have mutable references. So maybe if you take now, their car is white in color, but the white maybe it has one or two stain, maybe it has started fading one or two places. I can decide to tell Fitech that this your car, I want to borrow it but don't worry, this color the way it is, I'm not too satisfied with it. White is not looking too fine. Any small thing you see so can I paint it to blue? And then Fitech will be like, okay, no problem, you can go ahead and paint it to blue. Now it's not my car, but I borrowed it and repaint it to blue and return it. So that is the case of mutable reference. You are borrowing the value, but you are borrowing the value in such a way that is going to allow you to make changes to it, despite the fact you are not the original owner of the value, right? So now one thing you should always take note of in borrowing and references is that you can only have one mutable borrow at the same time. You can have multiple immutable borrow, right? 10 different people based on Rust, the law of Rust. 10 different variables or 10 different people can borrow one value at the same time. So far, none of them is planning to make changes to that value. So, but in an instance where at least one of them wants to make changes to that value, is only that one that can borrow it in the form that it can make that change. So, and why did Ross do this? Why did he put this kind of condition? Is to prevent what we call race conditions. So what is race conditions? Race conditions is when two things are making changes to something at the same time. In that case, you might not know which one is making which change and all of that. Maybe one is trying to increase it by 10, the other one is trying to reduce it by 20. So in that case, there will be always conflict in what the value should be. Okay, the value is now 40. The next one, I don't know. Is it the one increasing it that is going to use work out in this case, or is it the one reducing it that is going to work out? So to prevent all those things, they call it race conditions. So to prevent things like that, that's why they decide to come up with this rule or this law. So let's look at all these things we have talked about. Let's look at it in the practical sense. So now we have FN main. Remember, I told you main is always the entry point to your program. So let's say let s, okay, yeah, let's s be string from, and then let's say Rust, right? Now I know that if I want to, maybe I create another variable. Let's say let s2 be equal to s. I know that what has happened here is that I've actually moved the value of s to this. So it means after this point, s will no longer be valid. Before this line 4, s is going to be valid. So that's why from here, if we print our s, why am I forgetting this? So if we print our s here from this point, you see that it will not give us error, right? Okay, I can run it directly here. So you can see it's giving us what? It's giving us rust. But let me be using the command so that the thing will not look somehow, right? So let me open my terminal, and then if we do cargo run, so you can see it's giving us rust. But immediately I come after this line 6 and I say I want to still access the value of s, right? You see that I will not be able to access the value of s here. Why? Because I've moved the value of s from this line 6. I've moved it from s itself and I've given it to this new variable s2. So now even if I decide to run the program, you see that it will throw me an error. See, it's telling me that value moved here. It's even telling me where the moved occur, which is this place and all of that. So now let's say in this situation, I want s2 to have the same value with s1, but I still want s to maintain ownership. I don't want to move the ownership from s to s2. I still want s to be a valid this thing owner, to be the valid owner of this string rows. What am I going to do? That's when I will now do what they call borrowing. And how do I borrow? I borrow by attaching a reference. So what I have done here is I'm telling it that I need the value of SO, but I don't want to collect it. I don't want to grab it. I want to borrow it. So if you want to borrow any value in Rust, you have to attach a reference to the value. That's this ampersand. Some people call it and, but it's actually ampersand. So you attach it to the value you are borrowing. So this ampersand is referred to as reference. So once we do this, you see that if we run this code, we'll still be able to access s here. Why? Because s is not moved. Instead, what we did here was to borrow the value of s. S here still maintains ownership. So if we run our code, you can see that our code here is going to run. Look at it. Here it's pretty okay. Let me even put it as first s and second s so that we are going to see it second s. So let's run it. So you can see first s rust, second s rust. But if we remove this reference and say no, we just use s, what we have done here is to move the value from s here to this s2. So if we run this one now, you see that it will be complaining of move. You see value moved here, value borrowed here after move. So do you guys understand the concept of reference and borrowing now? Do you guys understand, or I should come
Yes,
again?
sir. So sorry, I just want to add. So
Okay.
borrowing and reference like can be used interchangeably and it's the same thing, right?
Yes.
Okay.
You understand?
Okay.
But it's just that the what they call this ampersand, they call it a reference. So by attaching the reference to the value, what you have done is to borrow the value.
Oh, okay.
You
Yes.
understand? Yes.
Yes.
Yeah. So any other question? So you can see that here we can even access both s and s2, right? S2, we can access both of them here. So if we run our cargo run, you can see s is rust, s2 is rust. So that is the whole idea of move and borrowership. Now let me see. before I talked about it. Let me check the next slide to be sure. Okay, so let me explain. Now if you remember, I want you to observe something. What is the signature here? The data signature you see here. You see a string, right? A string. And then what is the data signature you see here? The data type can also be referred to as data signature. You see ampersand string. So what he's trying to tell you here is that this one is a borrowed string. This one is a string and we borrowed this one. That's why this one is having the signature of a borrowed string. Now, if you remember, when we started the class, there was something I did that I was like, but it's supposed to fail now. Why is it not failing? So let's call it new s, right? Equal to, this was what I did, right? I did this. Now, who can observe what is the signature of this? You can see that the signature of this is called, and that's why the fact that they have this static, but don't worry about the static. This is the main thing here. So I don't know why this one is attaching static to it actually. So this is what it's supposed to be actually, an str. So now anytime you are using this in Rust, they call this one a string slice, a string literal. Yeah, they call it a string literal. It's quite different actually from string slice. Yes. So but the string slice and string literal are more like the same, right? But they have a little bit of difference. I'll still explain. So they call this particular one string literal. So by default, a string literal is a borrowed value, right? So even if I come here and say I create another variable, I say let new s1 equal to new s, right? Already this is a borrowed value already. So since it's a borrowed value, even if I take the value of this variable and give it to a new variable, I'm not moving it. What I'm simply doing is that I'm trying to say, okay, the same place where this value is stored in this variable, I'm taking that same, what is connecting these two, I'm taking it and connecting this one too, so that this one can always find this value here. So this is how it works, right? I have new st, I have it pointing at this value called Rust, right? Why? Because this one is actually a reference to this value. So this variable, this value is stored somewhere, and this variable is just pointing to this value. So by now saying new s1 is equal to new s, this is what I'm doing. I'm now saying that new s1, right, is pointing to new s, and then new s is pointing to Rust. I don't know how to do a multi-line something. Yeah, if not I would have so this is what is actually happening. This has a pointer to this value, and this one, right, has a pointer to this value. So with whatsoever this value is pointing, the end result is still this. So this is what is happening behind the scene for what we have here, and that's why for this one we don't even need to borrow the value. The value already is in a borrowed state. So that's why they call it this thing string literal. It's not like your normal string. It's not like that one that if you want to create, you use your string from. This one is the normal string, but this one is called the string literal. This one in its default state is actually borrowed, just like I said. It's because here you are seeing the signature is this, but the signature normally is supposed to be something like this. This is how the signature is supposed to be. You understand? So I don't know, the compiler is inferring that static something something. That one is, it has to do with lifetimes. Don't worry, don't bother yourself about that one. So this is why we can just pick this one, pick this variable, give it to this variable without being worried that the value will be moved from here. So I don't know if you guys now understand, like, why when I did it at the other this thing, what are they calling it, editor, it actually worked. So this is actually what is happening. You can see that if I mistakenly change this one, let me remove this data, this thing. If I mistakenly change this one to a normal string, there are two ways you can use create string. Either you use string from, or you use this you use a string literal, then you attach, you call the toString method on it. So calling toString method on this string literal, it has converted it from string literal to this normal string. So in this case now, you can see that if I perform this operation, what is happening is that it's going to perform a move, so it will not work. Look at, so look at, a moved has happened. So okay, sorry, I still put this. So you can see the signature is now a string. So if I run my cargo run, okay, I was not trying to access it. So if I try to access the new s now, let's say I try to access the new s, so new s, it will tell me that it has moved it. That's the move has happened here already. You can see it's already throwing me error. It's a borrow of moved value. So that's why the fact that I've borrowed it here, I'm now still trying to access it, which in this case is no longer valid. But if I don't want to go through all this hurdle of having to borrow, so to overcome this one, I just need to borrow. Why, if I don't want to go through all this stress of borrowing, I can just make sure it's back to string literal. And then even if I do something like this, if I run it, you see that it's going to work. So always take note of that for Rust. And also, if you have a normal string, right, that's, you have a value that is a string, you can always convert it to this string literal. Now how do you do that? You use dot as str method. So once you call the at dot as str method on a string, it will convert it to a string literal. So always take note of that. So string to string literal, you use dot as str method, whereas str to string, you use dot to string. So those are the methods from converting from one to another. So any question on this? All right, so you guys are sure, like, no question, we can like move on?
I just noticed that ownership, borrow, and referencing are very, very alike. So I just know that we just need to go and settle the syntax and all. But they are looking almost the same, because in ownership,
Yes,
if you declare a variable, maybe like s,
yes,
then s2, and then you do the move directly, you
yes,
cannot retrieve s1, and then this one too is
yes,
doing almost the same thing.
yes.
And so I think we can go and
All right,
battle with syntax. Yeah.
awesome, awesome, I love that. So that's it, that's it. So let's go further, right? And now, okay, let me even give an instance, right? Let's create a function so that you understand how deep this ownership is, because I know that this one we just made use of n, right? just normal variables. So ownership is big in the sense of, let's say we have, okay, let's have our main, which is our entry point first. So let's have a function. Let's say this function, what it does is to greet, and this greet now, it takes in the name of the person, right? So let's say it takes in name of the person as string, and then what it does is, okay, let's even assume that it did not even return. It just prints, it doesn't return. It just prints out. So now we can say, okay, it takes the name and then it prints out. It says you are welcome to Fee Tech, right? So it will mention the person's name first. So let's say this, you are welcome to Fee Tech, and then here we are putting in our name, right? Now we can come here, looking at this function. The function is going to take a string called name, right? And then whatever string it takes is going to print it out. Now by using string here, this function, what is going to do is that it's going to take the ownership of whatsoever thing we are passing into it. So if we come here now, we say let name equal to, let's say Christiana, right? I hope I even spell it correctly. So let name is equal to Christiana, and then we call this greet function and we pass in Christiana's name to this greet function, right? Now you can see that it's even throwing us an error. The program, it has already checked and it has seen. It say try using a conversion. Okay, the reason why it's giving this error actually is because here I say it should be of type string, whereas here I'm giving it a string literal instead of a string. So I have to convert it to string. Either I use the to.string method like this, or I create it using string from. So either of the two is going to work. So string from, so good. Now let's run this function. It means if we call this greet and we pass in this name, the value of this name is Christiana. So if we pass it in, it's going to now print Christiana, you are welcome to Fee Tech, right? So let's run it. So you can see Christiana, you are welcome to Fee Tech, right? But now, seeing what we have here, let's now say, okay, let's try to assess. You know, here we have already used Christiana here for this function, and based on what this function is taking ownership of the string, is collecting the string, right? By passing it to the greet function, it's more like it's performing it has collected ownership from the variable name. This greet now owns the value of this variable. So it means after this greet, before this greet, name is valid. After this greet, name will no longer be valid. How? Now let's try to assess name after this greet. In fact, we must not even want to print name. We can decide to say, okay, let new name equal to name, right? Now you can see already it's throwing error. Why is it throwing error? Because already the variable name have been moved here. Greet has taken ownership of it. So trying to access it after greet has taken ownership of it is no longer valid based on Rust. So even if we go ahead and do cargo run, look at what it will say. Look at move. You say move occurs because name has type string. Are you seeing it? Which does not implement copy thread. So look at our line 5 greet. It's telling us that this is the place where the value moved. It's a value moved here. And then imagine after the value has been moved here we are now coming and saying we want to now still use name after name has been moved. So you see value used here after moved. So now what do we do? Is either number one, instead of passing in name, is either you clone it, which of already I told you guys that cloning a value is performance intensive. So in this case, if we run our program, it will not complain of move again. Or instead of doing this, instead of just accepting a string, we'll accept instead a reference to a string. Right? So since we are accepting reference to a string, it means this is our name. We have to pass in it as a reference. Why? Because we don't want to move the name. We still want to have access to the name even after calling our function. We don't want the function to own the value. We want the original owners to still retain being the owner of the value. So in this case now, if we run our command, you see that it's working as it used to. Then the best way or the best thing to do in this case is to even make it a string literal. So making it a string literal, even if it's a string I pass in, what is going to happen is that I'm going to borrow the string here. So by borrowing the string, the function is going to accept it. Even if it's just the string literal itself, not even the string, the function is still going to accept it. So that's why they normally encourage or advise that if you are working with functions, instead of using string, it's best you go for string literal. Because if you use a string literal will accept both a string and also a string literal. But if you use normal string here, right, it will not accept a string literal. Let's say we use normal string here. And here, what we are now passing in is a string literal. This one will not accept it. You can see here, if we check, or let's run itself so that we'll see the error. So you see what it's saying here. It says, greet, try using a conversion method to string. Expected string found string literal. So they are trying to tell you that the function signature is not correct. Here, what the function is expecting is a string, but here what we are passing into the function is a string literal. But once we change the signature of the function to accept a string literal, you find out that if it's a string literal, the function will accept it. So if we run our program, you see that it's going to run. And even if we come and say, no, it's a string we want to pass in, not a string literal, right? Now, it's a string. What we just need to do is to add reference to it. And once we add that reference, automatically, the string literal is going to accept it, despite the fact it is actually a string. So, any question? Please ask so, because this is the foundation of Rust. Go on,
Can you zoom in
Tali.
a bit, sir?
You say?
Can you please zoom in a bit?
Zoom in. Okay. Is it okay?
A bit.
Okay.
Yeah, it's okay now. It's okay.
Okay. Awesome. So, if there's any question, please go ahead and ask, because this is the foundation of Rust: borrowership, ownership, and borrowership. So once you guys can have an understanding of this, any other thing in Rust is syntax and then understanding of why it's being done that way. So any question? So now let me ask a question, right? If okay, Tali, go on.
Sorry, I joined late, so I don't know what's the difference between the string and the string literal.
Okay, good. Now, string is an owned str. String and string literal are the same, but just that string is owned, and let me not say it's an owned, is owned. Why string literal, which is this, is borrowed? So string, which of course is still normal string, the data type is string, is owned, whereas string literal is borrowed. So if you create a string You are trying to say, I want the variable to have ownership of it. If you are creating a string literal, you are literally saying, I want the variable, I don't want it to have ownership of it. So that is the difference between both of them. So, okay, Johnson, go on.
So, sir, in a nutshell, what you are trying to tell us is that even if that value that you want to pass inside this grid function now, even if it's a
Yes,
borrowed value, is going to go, or own value is going to work, right?
yes, yes, yes. But always remember, if it's an owned value, right, you have to attach a reference to it. Why, if it is a normal string literal, you don't need to attach, it's not necessary to attach this one. But if you like, you can still attach it. Whether you attach it or you don't attach it, or it does not affect it, because already string literal is not owned, is a borrowed type. So whether you attach the reference or not, look at it, I attach it. If I attach it, I run it, it will work. If I remove the reference, I run it, it will still work. You understand? But once it is a string, once it is a string and I want to now use it here, I have to borrow it, or else it will complain of the signature of, look at it, let me show you. It says here, you can see it say expected and string found string. So here it's even recommending, it's even telling me what to do, that I should do what, consider borrowing it. So I should add the reference. So that is just the difference between the two. So Obed, you can go on.
Okay, so what you mean is that by default,
Yes,
we look at our borrowed by default, so you cannot borrow it again, right?
yes, you can borrow it again, right? But it's useless borrowing it again because it's already borrowed. Yeah,
Okay,
exactly.
okay, okay.
Yes, exactly. So because that's why you see, when we brought it back, you see that here we are attaching reference to it, that's we are borrowing it, but it did not complain. Even if we decide to remove the reference, it did not still complain. So in this case, you don't even need to borrow it because it's borrowed already. But for string that is owned, we need to borrow it if we really want to still make use of it after calling the greet function. So do we get it? Okay, go on, Obed. Go
Okay,
on.
sir. So what you mean is that any
Yes,
place you see a string literal,
yes,
instead of borrowing it, you can just use it directly without without adding a reference, this is ampersand
yes,
before the variable name, right?
yes,
Okay, so
yes, exactly, exactly. Okay, okay. Jethro, go on.
So, sir, for best practice, I think string literal is the most suitable one to use.
Yes, it is. But then the problem is that there are many instances where you will not be able to use string literal. You will have to make use of a string. You understand? So I don't know. We'll still come to that. But there are many, many, many instances where you would prefer using string than string literal. So Obed, go on. Okay, okay, I think maybe it's a mistake raising up his hand. So, but normally anything that has to do with function, always function parameter, please always make sure you make use of your string literal. But when it comes to struct, we'll still look at struct. In struct, majority of the time they make use of string, and I will explain why. Because that's when you can have the issue of partially moved values and all of that. So we'll still do that. So any question? If you are still finding it a little bit confusing, don't blame yourself, right? It's like that. first time you learn the Rust borrowership, ownership, is always like that. There are some things that will not be too clear. In fact, there are some things that you'll be thinking, like, when should I use this and when shouldn't I use this? So it's with time. As you keep using Rust, with time you get to understand where to
Ah,
use what.
you are just on my mind, though. You just said what I was thinking.
Exactly. That's why I sent that emoji. I just wanted to ask what scenario are we going to be using this?
Honestly.
Okay, Johnson, go on.
So, sir, if I could add, like from my own understanding, let's just say we have kind of like a contract now, like a state and a local variable. So now you are trying to tell us that in a state variable, we should use something like string, right?
Okay, we never enter contract to Johnson. Don't worry, we'll get to that.
Becoming
No, sir,
down,
like I know,
becoming
like what I
down.
mean, if we use string literal,
Yes.
like if we use string literal, the value is going to move from the state to maybe where we used it in maybe our function. That's what I'm just trying to ask.
Okay. I get what you're saying. Yes, that's what is going to happen. Now, just like I said, programming is like intuition, right? It's just like when sometimes you just sit down and you feel something is wrong somewhere, and then later you find out truly something is wrong, right? Or you feel I just feel this week money go enter my hand, and then money came. So that's how Rust too is. There are some things that you might be thinking, where should I use this, where should I not use this. Now, as you keep on writing Rust, that's when intuitively you begin to understand where you are supposed to use what and the rest. You understand? So for instance, now, let's say I want to build this function, and what I want to use in this parameter is a string, and I want to do it in such a way this function, right, this function will not take ownership of this, and a string I want to use. If I like, I can decide to use a borrowed string, since I know by doing this, what I'm trying to say is that greet at every point in time should just take a reference to the original string. It should not take the string. I can decide to do this. But to make my program more robust, that even if somebody comes and passing just a string literal and not a string, what should I do? Instead, why not I make it a string, since I know that a string accepts both the normal string literal and the string itself. And I can decide to say, okay, yes, I'm stubborn, I just want to use normal string, I must use string. But in this case, I can say, okay, I want it that greet we take ownership of name, but that name is taking ownership. It should give me back, it should return it back to me. I can decide to say, okay, this function greet will return a string. And what is the string that I want it to return? I want it to return the name. That's the same name that is collecting. I want it to give me back the name. So who can tell me what did I do here? Which type of return type is this in Rust? We did two return types last class.
Implicit.
Good, good,
Implicit.
good. So this implicit, right? The one you don't have to use return. So if you like, you can use return, right? But in this case, you have to have a semi-column at the end, or you just leave it as it is, the name of the variable you are returning. So what I'm doing here is that I'm telling it that, okay, take ownership of name, but at the same time, once you take ownership of name, you print it, return back a name for me. So what I'm expecting this greet function to return name. So in this case, instead of just calling greet function, I can say let name, or since I've already declared name, I can say name equal to this, right? What are they saying? Okay, string, sorry, so I have to remove this. I have to remove it, and this one too I have to make it to be string, because it's expecting a string. So what is he saying here? Cannot mutate. Okay, instead of name now, let me just say let name. Let me redeclare it, right? So what they call this in Rust is that they call it shadowing, right? Where you can redeclare variables over and over and over again. So they call it shadowing. Although one thing with shadowing is that if I come here and say let name and is a string, I can't come back and say let name be equal to 78. It worked though. I was thinking there are instances where it cannot work. Okay, no problem. Probably we'll look at that later. So what have I done here? Grit took ownership of my name, but at the same time, I say as you are taking ownership and using it to print, once you are done printing, please return it to me. And then this is me returning the name back. So here, what did I do? I redeclare name here because why? I know that I still need name. So I redeclared name and I assign the function greet to this value name, because I know that anything the function is returning should be stored in variable name. So in this case now, I will be able to access my name here. So if I run this program, cargo run, you see that it worked. Christiana, you are welcome to Fitech. So it's still everything based on intuition and based on what you want, based on your design. So everything still boils down on what you want. You understand? So and after all, this one self is over engineering. I believe you know what over engineering is. Unnecessary trouble. Because imagine, just because of this, I have to introduce this, another variable and all of that. So this is over engineering. So best thing, just let's take our string literal, remove anything return, it's not needed, and then here I remove this, and here I borrow the value. So here now everybody wins. Ross win, me too I win, cargo too win. If I run cargo now, I no go complain. So some things, there are some things that is based on intuition. So but the most important thing is that you understand that okay, Ross to move, this is what happens when you do this, the value move. This is what happens when you, if you don't want it to move, you borrow. How do you borrow? You attach a reference to it and all of that. So any question? All right, so let's okay, go on, Tally.
Sir,
Yes.
when you borrow,
Yes.
and
Yes.
you change the, let me say, you borrow and you updated the, let me say you change the variable data, the
Okay.
data attached to the variable,
Good.
and you returned it back. Is it going to
Yes.
return the change variable or the change data, or it will return the previous one?
Good. Thank you so much for bringing that question. In fact, I don't forget. If you look at the material we are using, right? If you look at, they talked about mutable reference, right? Where I explained that you can borrow a value, make changes to the value before returning it. Just like I was using the car as an illustration. Let's say you borrow the white car, and then you are like, this white color is somehow, this car would have been more better looking if it were blue, and then you use your money to paint it blue, right, before returning it. It's not your own, but you're able to change the color before returning it. So the same thing too is applicable to Rust. So let's say now this is our name. In this case is Christiana, but now we now say Kai, Christiana have gotten, she want to move to, she will be no longer available for like 2 weeks. So for that 2 weeks, let's change the name to Tally, right? So we can decide to say, okay, now name here is a string, right? I want to borrow the name to and give it to a new name. I want to borrow the name and give it to new name. What should I do? Of course, to borrow, we say we have to attach what? We have to attach an ampersand to it, like this. That's what we said. But in this case now, what I want is not just to borrow, because if I borrow it here, what I can just do is to read the value. What it means by read is that I can't change it. I can only read it. Let's say I want to print it out, but I can't change it. So, but me, I want to change it. I don't just want to read it. I want to change it, but I don't want to change it directly. I want to change it I want to borrow it, then change it. What should I do? So that's where we now have the mutable borrow. And how do you have the mutable borrow? You have your ampersand, mute, and then of course string. So what is this one saying like this? Expected new string found as string. Okay, so and okay. Let me confirm something so that I'll be sure. So let me. Okay, go on, Obed. Expected this, found this. Go on. Okay, Tali, go on. It's as if Obed dropped off.
I think it's because of the and you added before the mute, something like that.
Really?
Okay.
Okay. Obed, yes, I'm hearing you.
The and supposed to, I think the new is supposed to be after the leg.
Okay. That's this mute supposed to be after.
Yeah, before the variable name you are borrowing. Before the variable name.
Okay. Oh. You mean like this? That's true. Nasiba. Old age. Hey God. No be old age, yeah. Then why is it showing error? Mismatch type, expected struct string, found mutable reference. This is surprising. We borrow using ampersand, right? So ampersand mute cannot move out of a reference. Wait, let's see the advice these people are giving us first. This is surprising. And mute v. Yes, go on, Johnson. So this is it actually. Sorry, Johnson, you can speak.
I wanted to say you should put the mute before the new name, then this place you added mute in front. I don't think it's supposed to be mute. It's supposed to be ampersand name.
Okay. Now, this, if you guys remembered, we said to borrow from string, you add an ampersand, right? Then whatever you are borrowing follows. So here, what we have here is name, right? Which is a variable and is an owned value because it's string. I told you that string is owned. So, but here, want to borrow this string, the value of this string, which is Christiana, attached to this variable. But we don't want to borrow it as a mute. That's want to be able to change it. Despite the fact we are borrowing it, but want to be able to change it. So that's where the concept of referencing mute comes in, right? And mute name. Now, the reason why you see it's throwing an error here is because what we are trying to do here, we are borrowing it, but we are borrowing it as a mutable value, as a value that we can actually change. So in this case, if we are changing the value, it means it's this original value we are changing. So this one too have to be mutable. So we can only have a mutable reference to a mutable value. If the value itself is not mutable, we can't have a mutable reference. But if the value is mutable, we can either borrow it as normal borrow, that's we are not planning to change it, or as a mutable borrow, that's when we are, that's in this case it's more like we are trying to make changes to it. So in this case now, I can come back here and say, okay, oh, my new name will now be, let's say, tally. Let me use string from, so that people know that there's something like that. String from tally, right? So let's see, what is it saying? Expected and mute string found string. These people, wow, Rust. So let's try this and see if it's going to work. Or it's not working. Cannot assign twice to mutable value new name. These people are funny. So it means we have to make this one mute too. Hey, people should help me out here. Let's debug this thing together. Okay. Okay, so instead of this, let's try something and see. Let's make this one let. Oh no, we are redeclaring it. So what is happening here? Borrow this one as mutable. Let me take this one off first. Okay, you know what? Let's make use of this grid, right? Let's make use of this grid to change the value of this name. Instead of trying to do this, let's use a function. So let's create another function. Let's name it change name. So, and then since we are changing name, the name now, it's going to be a mutable reference, right? So we have mutable string. Are we returning anything? No. Or should we? No, let's not return. So to take a mutable reference, and then it's going to change it to okay, let's name equal to, let's say, changed name, right? Dot to string. So let's try this and see, is this really valid? Is it valid? So mutable reference, and then change it to no. But there should be a way of doing this now. Let me try. Come here. Let me try something. Name dot replace. Good. So let's do this and see. So it will take in name, and then it will replace it with string from, let's say, tally, right? Tally, yeah. So is this thing not supposed to work? Found string, consider using a okay, sorry, semicolon. So what are they saying here? Replace from name is a string dot replace from p to p pattern. Okay, follows pattern. So let's say from coming string, I don't often use this function, so he Christiana. So let's be sure. Required by bond. A implement replace convert an str into this. What is this thing saying? Okay. I don't want us to return it. I want us to change it. Okay, let's try the normal one first. Let's see. So let me say print ln name, right? So name, formatting specifier missing. Okay, sorry. So let's try this one first. Let's see. Change name and name, right? So let's run. Okay, so this one is working. So let's see if you are taking and mute to the string, and then we want the name to, let's say name is equal to tally dot to string. So what is it saying? Mismatch type expected and string found string. Consider dereferencing. Okay. Let new name and then name equal to new name, right? What do they say? Mismatch expected this, found this. What is happening here? This is strange. Okay. Oh. Found str. How is this str? This is a string. Yeah, passing it here. Hey, mute. Okay. So you know what? In order not to waste our time, we'll come back to this. This is funny. Wonderful. Hey, what does shall never end today? Hey, Kai, this is serious. Mutable name. Christiana. Okay. Wonderful. Okay. So people are just looking at me like this. Nobody say anything.
Straight never reach you.
What do you want to achieve?
Okay, what we want to achieve, right? We want to use a mutable reference to change a value instead of changing the direct value. You understand?
Yes. Okay, so what we do This in the change name, right?
Yes. So let's look at it
You are
very well.
passing the passing name as a parameter inside the.
Yes. Okay. I think I know what is happening. So if we are this one now from this signature function signature, we are passing a mutable string. So here too, for this particular one, if we want to pass in the value of this, we have to indicate it as a mutable. Me, I was thinking once is made mutable here, we don't need to what are they calling it? We don't need to indicate it here, but it seems no, we have to indicate it here too as a borrowed mutable value, right? So in this
Yes,
case now,
because
okay, you're saying
as
something?
a mutable. Like, is it because in parameters we pass like the name, so we also using it as a mutable value, right? As a
Yes.
borrowed mutable.
Yes. So the value itself, you know, I told you, since this is the original value we are trying to change, this original value we have to make it mutable, because without making it mutable here, it's not impossible to change it even via reference. If you want to even change it normally on a normal ground, you have to make it mutable. Talk more of you are not changing it through a reference. So you have to first make it mutable. Then if you are passing in the value inside the function you want to use to change it, you have to indicate that is a borrowed mutable value. If you just put it as, this was the mistake, was the mistake we are doing actually. We are just passing it directly, assuming, right? But it's not like that. So you have to pass it in that is actually a mutable borrow, and then you pass in the value. So in our function here now, let's say we want to change, we want to make changes to this, right? So let's, which method can we even use? Name dot, let me see any of the method we can actually use. I wanted to use replace before so that we just change the whole thing, but since replace is taking in 2, I was expecting it to take in 1, so that what it's going to do is that to just replace it with itself. So that was what I was thinking that is going to happen, but since that's not the case, so it seems we'll just use another thing. We can use all these ones to lowercase, to uppercase, and all of that. So but let me see, push. Okay, let's use push str then. That's now the difference in this push and this push str is that push, normal push in Rust to a string, you can only push one single character, but push str you can push a whole string to it. So let's use push str. So let's say this push str now, originally here we have Christiana, right? So we can decide to say Christiana of, let me give a space first, of phi tech. Yeah, Christiana of phi tech. So what we are doing is that we are taking this our value, whatsoever value we are passing to this our change name function, we are taking it and then we are pushing this string, we are calling this push str method, and we are pushing this string of phi tech. So it's going to add to what is there as name already. It's going to add this space of phi tech. So if we come now, we call this function now. Now let's print out name and see if whether this function has really changed the value of name. So before that, let's print before. So we'll print before change name, or just before, so that you don't have to be typing long type. So before we have name, and then okay, let's copy this thing, then this one will be after. So we have before and we have after. So let's check if this function has actually done justice by adding this of phi tech, and then we'll do cargo run and see. So you can see before Christiana, that's before we call this function that made changes, a mutable change. Before we call the function, we had the normal name, which is Christiana, and then after we call the function, we are still printing the same name here. This time around, you can see is now Christiana of Fitech. So that is how you actually do a mutable borrow. That's how you work with a mutable borrow. So instead of just borrowing it just to read it, you can also borrow it to make changes to what is there. So any question? Hello, any question? All right, no question. So let's continue. Does that answer your question, Tali? Is he on the call at all?
Yeah, at least it
Okay.
explains a lot.
Okay. So that's how it works. So always remember, because I think that was where we're making a whole lot of blunder. Always remember to attach that and mute to the call. Once you are calling the function and you are passing in the variable, don't just pass in the variable. Always pass in the reference, the mutable reference. If not, it will not work. Despite the fact this one is showing that it's mute already, if you pass in this now, it will not work because this is a reference but not a mutable reference. And what you are doing here is you're actually mutating the value. So always remember to pass in your mutable reference. Yeah. So all right. So let's look at, now we have what we call options. Option type in Rust. So now how Rust works is that if you remember in JavaScript, you have something like null, right? Null to show that probably is empty, something of that nature. Now Rust have what we call option. So option is a situation where you are not sure whether you are getting a value. For instance, now you wake up in the morning, right? And maybe the sky is clear, there's no sign of maybe cloud or rain. If I ask you that will rain fall today, you might tell me that it might fall and it might not fall. So that is where option comes in Rust. So option is more like, is either I get the value or I don't even get any value at all. You understand? So in a situation where, okay, you are expecting a value and that value you're expecting, you might not even get any value at all. So that is where option is being used, and is used for any or every data type. So if we come now, we can say I can say let's value, normally let's say value is equal to 3. But now I can decide to say, but this value, sometimes it might not be 3. Sometimes it might be none. There might not even be value at all. So in that case now, I can say, value might have a number, I might not even have anything. So I will make it instead to be an option I32. So in that case now, I will now say, okay, if I'm giving value, that's this variable, if I'm giving it a value, that's in a situation where it has a value, I can come and say, okay, in that case it has, let's say 45. And in a situation where probably is not going to have any value, I can say, value in this case will not have any value, or instead of value, so that it will not be confusing, let's just use number. So in this case we can say, okay, the number might not even, it might be empty. So in that case I have to present it as an option. So option, I can either have option of having a number or option of not even having a number at all. So for option, you always have two values, either none or sum. Always put that at the back of your mind. For option is either you have a none or you have a sum, right? So sum, you have a sum in a situation where the value is present, and you have none in a situation where the value is not present. So that is how option works. So I don't know if you guys understand the concept of option.
So you can go over it again, like those ones, yes.
Okay.
Mm.
Okay, good. So let's say I have I'm trying to use a real world case scenario. I don't use result because that of result is plain. It's either you get a value or you get an error. So that one is synonymous to try and catch. You know, try and catch in JavaScript. So I'm trying to check for this option, right? What should we use as an example here that will really okay. We have not done struct. I would have used struct. No problem. So let's say let cash. Good. Let's say I'm operating a POS, like I have a POS outlet, and then I go to the ATM machine to withdraw. Now, since number one, I'm not even the owner of the ATM machine, for me to know whether there is actually money inside or there's no money inside, right? So I can now decide to say, if I want to go and withdraw in this ATM, if I put my ATM card, I put my PIN, I enter the amount I want to withdraw, is either I get that amount from the ATM, or that's in a situation where there's cash in the ATM, or I don't even get anything from the ATM. That's in a situation where either there's no cash or cash has finished. So there's no how the ATM can even give me, the ATM machine can give me any cash whatsoever. So in that case, I can say, okay, let amount, right, be option. And since it's money we are talking about, so we are not expecting a negative value, so we can just use U64. Let's say the amount that Jethro wants to withdraw is very big. So let's say what I want to withdraw, or what Jethro is planning to withdraw is, let's say he's planning to withdraw let's say 100,000, right? So remember in my last class what I told you, putting this underscore is just like a way to maybe make your number more presentable, but it's not always necessary in Rust. So doing this is the same thing as doing this. Rust will recognize both of them. So now it's possible that in ATM A, right, Jethro wants to remove 100,000 and is planning to remove 50 from ATM A and 50 from ATM B, right? So from ATM A, it means what is he expecting? He's expecting 50,000. Now, the amount Jethro is expecting is, the data type is U64, and because I think U64 can carry up to 50,000. But now, why he's making he's making this U64 as an option. Now, why is he making it as an option? He's making it as an option because number one, it's possible that if he goes there, he will get cash from the ATM. So in that case, he's assured of getting his 50,000. And also, he knows there's also a possibility that if he goes, there might not be cash in the ATM. So in that case, he might not even get anything from it. So let's say the ATM A, this is ATM A. He was able to get the 50,000, right? So 50,000. So in this case now, what he's getting here is a sum. And why is this thing show? Okay, sorry, I'm using 3. 3 is for documentation. It's supposed to be 2, sorry, for comment. So here now, for every value you are getting from an option, the value is always enclosed inside a sum. Now I will explain why in a way they did this. We'll still come back to match, right? So we can now say, Kai, we want to check. I think we did match statement last 2 days. We can say, we want to check. Did Jethro really get anything from this ATM A? So we can say, okay, match amount. Now we want to check if he actually got something. Match amount. And what is he matching? Sum. Of course, we say sum is a representation of when you have a value. So we can call it value. You can name it anything, anything you want. Anything. So let's say amount. Now what we are trying to say here is that we are matching the sum. Remember, I told you sum is always when you get a value from an option. So we are not saying, okay, if you actually get a value, what will you do? Print for us. Carry out this action. Print for us. Jethro got. Then it should print the amount for us that Jethro got. So this is in a situation where Jethro is able to get money from this ATM. But in a situation where he's not able to get money from this ATM, it's going to be none. So in that case, you should print, let's say, no money or no cash. Let's just print this one, no cash. So now, if we come now and we say, okay, so if we run this code, what is going to happen here is that already here, from the value we have given to this option, we have given it a value of 50,000. So if it comes here now, it will check what is amount. Is amount a sum? Of course, here amount is a sum. It will not check sum of what. Of course, here we say let the value inside the sum, let it be represented using AMT. Just like I say, you can use anything. So now what we are doing here is to now print out whatsoever value is inside of this sum. And we are now saying, okay, in a situation where there is nothing, is none, print, give us this. So if we run this code now, you can see that what did we get? We are getting 50,000. Why? Because we're actually getting a value here. I told you that for every value of option is always enclosed inside a sum. So it's just a syntax kind of a thing. That's how it works. But in a situation where probably Jethro went to ATM B, he's trying to withdraw. He wants to withdraw the remaining 50,000. And then this ATM B, unfortunately, there's no cash. So in that case, what Jethro is expecting from this is option is not a sum, but instead a none. So by matching our amount, you now find out that, okay, if amount is none, just go ahead and print this, which is no cash. So if we do this, you can see what we have here, which is what? No cash. So is there any question? Now you must not do this. This one is just a check. If you want, right, you can print the amount directly if you want, right? So if you want, you can. You must not use match statement. So match statement is that I use there is just to suffice for any kind of situation. Now, if you remember what we did last class, there was something where when we were about printing array, where we are not able to print it, right? So this one too, to print anything that have to do with option, you have to use your debug. Either you use this one in a situation where you want it to everything to be on one line, or you use this one in a situation where you want it to further beautify it. So in this case, if we run this code, look at, it's going to tell us the value of amount, which in this case is none. And in a situation where we had, maybe we're able to withdraw some cash, we have to enclose the cash inside this. So let's say he was able to withdraw, let's say 70,000, right? So if we run the code now, you can see it's giving us what the value of our amount, which is sum 70,000. So do you guys understand the concept of option now?
Yeah. So it's just like a boolean variable where instead of returning true or false, it returns the data, the value
Good,
attached to it, like a custom value.
good, good. So instead of just saying true, is there amount? True, is there amount? False, right? Two, is there amount? Yes, and the amount is this. Is there amount? None. There's no amount. Exactly. So any other question? All right, our time is even fast spent, so let's just try and finish this slide. Our second slide, the second slide I prepared, probably it's going to be our next class. All right, so let's look at, okay, so this option you can actually play around with it and all of that if you want to. Then let's look at result type. So another type, very important type in Rust, is result. Now this one is the one that is comparable to try and catch in JavaScript. You know, try and catch in a situation where you know that this thing might fail, and if it fails it might result in an error. Then you are trying to handle both in a situation where it's successful and a situation where it fails. Of course, in a situation where it fails, you are expecting an error. So that's exactly how result 2 works. All right, so now just like how option, always remember option has some or none. Result 2, or let me just clean up this. So result 2, okay, let's use a different function here. So let's say fn divide, and let's use the divide function here, and then let's say this divide is taking two numbers. Yes, okay, go on. I think somebody is raising up their hand. So let's use I32, right? And then this divide, should it return something? Okay, let it return I32. All right, so now for result will return either an okay or an error. So in a situation where it's successful, it will return an okay. In a situation where it's not successful, it will return an error. So now what we want to return is we are returning a result. And then in a situation where it's successful, we want it to return an I32. While in a situation where it's not successful, we want it to return a string. Now that is one thing with, remember, just like your option 2, you can signify option of what are you expecting. Is your option of I32? Is your option of string? Is your option of boolean? So the same thing with result 2. Result, just like I said, it has two parts: the success, that's the okay, and the error. So the success, which data type is the success supposed to return? Which data type is the error supposed to return? So you have to indicate. Now our divide, remember in your calculator, if you do 0 divide by a number, right, it will give you 0. But once you do a number divide by 0, it's going to throw a math error for you. Why? Because a number divided by 0 is actually infinity. So but your calculator does not have that much memory. So I don't think there's any memory that is infinity, unless maybe the human memory, yeah, probably, right? So that's why your calculator always return math error or any other thing like that. So that is what we want to check and then propagate as error in a situation where somebody is trying to divide a number by 0. So here we can now say if, because based on we want to do a divide by b, that's how we want to structure this division. All right, this division sef will not even work if we are returning I32. It will cause an issue, although no problem sha. Let's just go ahead. So we can now say, in this case, if b, because it will always be a divided by b, so we can do 0 divided by a number, but it will be impossible to do a number divided by 0, and it also be impossible to do 0 divided by 0, because 0 divided by 0 will still lead to infinity. So we can check and say, if a is equal to 0 and where is and of course we understand what this one is, and b is equal to 0, right? What do we want it to do? We want it to return an error. And remember, we say the error type should be a string. So here we now say both variables cannot be 0. So remember, we are using a string, and what we just supplied here is a string literal. So if you like, you can decide to say, what you want is actually this, but it will even still throw an error. I'll still explain why. So this is one of the cases where you cannot use a string literal. So that's why I say I was telling you guys that despite if a string literal is great, but there are instances where you cannot use string literal. So for we to use string literal here, we have to indicate what they call lifetimes. So we'll still come back to that. It's not now. So we'll just go with our normal owned value, which is string. Now this is a string literal. We have to convert it to string. So we'll do dot to string, right? That's if a equal to b. Now, why is it throwing an error here? It's throwing an error here because we have satisfied the error part, but we are yet to satisfy the value part. So now I want to check for this, and I also want to check is in a situation where b is equal to 0, right? What should we do? It should give me return an error that says cannot divide by 0. Cannot divide by 0, right? So of course you have to convert it to string to string. And then finally, that's if none of this gives us an error, what should it do? It should return, remember what I told you guys, that this part, the success part, you use OK, the error part, you use this error, ERR. So it will now be A divide by B. So this is, what is this one saying? Mismatch type, expected enum this, found unique type this. What are these people saying? Remove semicolon. Oh, sorry. Yeah, so this is it. So Rust compiler is actually very, very helpful. Yeah, very, very helpful. That's this Rust analyzer, both the compiler and also the Rust analyzer. So please make sure you download it. So now, of course, I believe everybody knows what we are trying to achieve here. We are trying to divide, but then we know that depending on the input we are giving the divide function, it can either result to a success or it can fail. Now in a situation where we are dividing 0 by 0, division will not work. Even if your calculator, if you open your phone calculator, you do 0 divided by 0, it will not work. So in that case now, we want to return an error telling the person that this operation is not successful, and this is the reason why it's not successful. It's because both variables cannot be 0. You understand? You can put is your choice. You can put anything. Maybe 0 divided by 0 is infinity. Just your choice. Then now we're also checking in a situation where b, the person is supplying 0 here, because it will always be a divided by b. So in a situation where the person is supplying 0, it means it's anything a divided by 0, which anything number divided by 0 will also give you infinity. So we don't need that. So we have to also return another error telling the person that in this case you cannot divide by 0. But now in the case of where it's neither supplying 0 here nor supplying 0 for the 2, it should go ahead and divide the two variables. And then just like I said, the success part of result should always be returned using OK. Just like how your options, you always use sum to return value. So once we do this, we'll just come to our main function, and then we can say let's say a b equal to let's say should we say 2 and 5. Yeah, that's why the fact this one will cause problem. So let's just say 6 and 2. Let me put what can divide perfectly, and then here I'll just call divide and then call the a and b. Of course, I'm expecting divide to return something, right? So I'll say let result, no, just give me normal result. So I'll store whatsoever divide is returning into result. You can see by default the Rust analyzer has already even given me the signature of my result. This is what is returning: result I32 and string. So here now I can now come and print my result, whatsoever my result is. Then here I just call it result. So now why this one is giving me error is because I'm trying to print it just like how I'll print a normal variable. But this is not a normal variable. This is a special type, just like how your option 2 is a special type. So for this special type, I have to use the debug mode. Either I use this, that will everything will be on a straight line, or I add this to beautify it, that everything will be on a straight line. So now if we do this, of course what we're expecting here is to get 3, because 6 divided by 2 is 3. So if we run this code, cargo run, you can see not just 3, but it's giving us a result, the success part of the result, which is 3. Now if we decide to make this 2 to be 0, right, and we print it out, let's see what it's going to give us. So you can see, because of here we are making b 0, we have already said that if b is 0 here, should return an error of cannot divide by 0. So you can see our result is now an error, with an error message that it cannot divide by 0. And if we change also here to 0 and we run, you can see it's now returning this first error here that says both variables cannot be 0. So that is the use of result. Success part, error part. The success part returning use OK. The failure part return using error, ERR. So any question? This is a place quiet like graveyard. Hope you people understand it.
Sir, is the result a special keyword?
Yes, result is a special keyword, exactly. Capital letter R, right? You can use small letter r, but the capital letter R is a reserved keyword. Same with the option. So any
All right, thank you, sir.
All right, you're welcome. So any other question? Any other question? All right, so we'll soon. Okay, somebody wants to speak. So we'll soon be done, right? Good. So now, if you look at what we just did right now, right, you agree with me that we were not able to get the direct value of results. So let me go back to our code. Look at what we had. We are always having not the value but the type plus the value. So in a situation where it is error, you always see this error here. In a situation where it is success, let's say 6 and 3, you see the value but it will always be inside and okay. So there is a shorter form, a shorter way where we can use to get our result or error directly. So how do we achieve that? We use what they call question mark. Now, observe something. You guys should observe something. When there's no question mark, what did you see? You see result. You see in the result, is either we have success of I32 or failure of or error of string. But immediately I put the question mark, look at what is happening. You can see that this question mark now was able to retrieve the results, the success part of the result. But now, the problem there is that immediately we put question mark, you can see question mark is giving us error. The reason is because for every function that you want to use question mark for, that particular function you are using it inside, you have to change it to a result type. So I just hope I'm correct. So what is this one saying? Mismatch type. Okay, no problem. So let's give it this. Let me try something. I hope it works. It did not. It's supposed to. So let me see what these ones are saying. Implicitly returns this as its body. Okay. Yeah, I get what they are trying to say. So now what I'm doing here is that, just like I said, for you to use this question mark, any function you are calling that particular thing you are using question mark to get the main value of the result, you have to convert the return type of that function to a result type. Now this main function, I don't really want to return anything from it. So that is why in the success part of it, I'm returning a unit. This is called a what? A tuple. I'm returning an empty tuple. So now what I need to just do here is to return okay, because that is what this signature is requiring. It's requiring that we return a result having a tuple signature. And I told you that to return the result, the success part of your result, you always use the okay. Now this is my okay, and what am I returning? I'm returning a tuple, an empty tuple. So I'll come here and include an empty tuple. So what is this one saying again? This is no use me joke. Okay, let me change this one to string. Yeah, so I think it go settle the fight. Yeah, so this is it. So I don't know if you understand. Now if we print out this result, we don't need to even do this again, because right now what this one is doing for us is that is calling this divide, getting the result, then pulling out the real value of the result for us. So if we run this code now, you can see that we got our value. Unlike before, you see that we'll be getting okay, but here now we are getting the main value itself. So that is the use of this question mark in Rust. And in a situation where it's an error, let's say we have 0 here, right? If we run this code, it will return the error for us directly too, without having this. Formerly it was returning error, but with this ERR, the error type. So now it will just give us the value straight up. So the same thing too, if I change this one to 0 and I run, so you can see it will give us the error directly. So any question? Any question? Do you people understand? So let's even do something, right? Let's try something. Now, let me create another function called results. Of course, I don't expect this function to take anything, right? What I just want to do is to call this divide function. I don't want to call it inside this main function. I just want to call it inside my divide function, right? Sorry, I want to call it inside this my result function, or let me call it run. Let me not call it result so that I will not have naming issues. So I want to call it here. Now let me ask a question. Here, as it is now, is giving me the result type, right? Okay, I need to copy these ones too, the values here. So this one is a choice. So before somebody go say, where this man go get this thing, is a choice. So if you like, you can just do them individually. Let a equal to 3, right? And then let b equal to maybe 5, or no, well, let's say 1, right? So okay, let result good. So now print, we are printing out result here. Results, yeah. So results, yeah. So we are printing out result here. Of course, you know this one is the main result. That's why it's throwing this error, because it wants us to use debug mode. So now let me ask a question. If I want to pull out the direct values, either success or failure, from this our divide function, what am I going to use, or what should I use?
It's a question mark now.
Okay, good. So I've add question mark. Now you can see that what we should be expecting is the direct result or direct error. But now the problem is that why is our question mark giving us this red line? Why is it giving us this error?
Um, because you've not converted the whole function to accept the question mark of it, like the way you did up there
Good, good,
before.
good. So always take note of this. The reason why I had to bring this up is because there are some code base you go to and you want to do something like this without remembering that for every function, any function in which you are performing something like this inside, you have to always return a result. So now here too, I'm going to return result, and then of course for the success part I just want this, and then for the error part I want this. Now remember, the error part here should always match with your original error type. So you can see here is string, you can see that here too I'm using string. So now, because what I'm doing here is that I'm trying to say I want to return a result from this run. So it means this run function wants to return something, either return a value, a success, or return an error. So in this case, to return a success, remember I told you, you always use OK. And then here what I'm returning, I'm just returning this. In fact, I think we can even return this. Let me try. I've not tried it before, but you know, agree work. That means we only have the option of using an empty tuple. So okay to return the success part, then the empty tuple itself is this. So now you can see that we no longer, this our question mark, there's no longer error there or whatsoever. So this run now, I can come here in this place, I can remove all of this, because in this main function, since it's not inside this main function, I'm using that question mark, I don't need that result again. Then what I'll just need to do here is to just come and call my run function in my main, right? And then what I by doing this, I'm expecting that it should give me the result of 3 divided by 1, or instead let's do 10 divided by 5, right? So if we run this code now, you can see what is it telling us. The result is what? Is 2, of course, from what we are printing here. So now Rust very thorough. So you can see it's even telling us that there's a variable we are not using, because this return now, this run, right, automatically this question mark is making it to return a value, and then it's telling us that we are not actually making use of the return value. So it's asking us to add a let, then an underscore. So in Rust, if there's any value that you are not using, you always append an underscore. Either use just a pure underscore, or you append an underscore at the beginning of it. So I can still decide to use a result to give it a variable, but putting an underscore here, I'm trying to tell us that just ignore this variable. I'm not going to use it anywhere in my code. So either you do this, or you just leave the underscore as it is.
Sorry, sir. Sir, what if you do not put the underscore? What will happen? Is there anything that will happen to your code?
No, nothing. It will just warn you. You know that kind of thing that you want to fight somebody in your class, but you don't have power. It's I'm warning you now, and touch me again, make you see. So that is what Rust.
Cross this line.
Cross this line. So that's what Rust is actually doing. So it's just trying to warn you that okay, there's a variable that you are not using, but it does not affect your program in any way. You understand?
Yes, sir.
So whereas in a situation where we have an error here, let me change the, so let's say we have 0 here and also 0 here. If we run the code, oh, this will not even give us anything. Damn. So it means we have to print for the error. That's where we have to even give it a variable, so that we can print out the variable. So imagine this one now to make us to use another question mark. So I'm giving you people this task. Now you can see that this thing is not printing. I'm coming. Let me just undo. You can see that for the error, nothing is being printed, right? For the value from here, if we make this one a value, let's say 90, and then let's say 10. If we print, you see that it will give us a value. It will print it out. But for the error, it's not giving us any value. So this code now, I'm going to paste it. I'll copy it now and then paste it on this chart. So you guys should copy the code and then try and resolve that issue. So this is the code. So try and resolve that issue. That's the issue where error is not printing, but normal result is printing. So I want you people to play around with the code and do something about it. So any question? Because I think this is the last slide. So you can see the question mark operator in Rust automatically returns the error if one occurs, and then cleaner than nested match expressions. So what do we have? Good. So this project is what we are supposed to build, but our time is fast spent. It's night already. I know some of you are already feeling sleepy. Why some people don't want to eat. So I guess okay. Okay, go on. Johnson, go on.
So please, is on this thing, the code is not all of them that came, so we cannot run it here. Maybe you just drop it on maybe WhatsApp or GitHub. Let's get it from there.
Okay. So okay, no problem. I'll do that. So any question? Hope Rust is still simple. This one that today is quiet like this. Abi as rain fall, code they catch some people. Let's say code they catch it through.
Yes, sir. In regards to that, this thing we were trying to change,
Yeah.
I think one of the issues we were having then was because we were not using string literal.
Okay, that's we're trying to when we are trying
Like
to
get the value, yeah, from the first one to the second one, and from the second one change it from Christian to tally, yeah.
tally. Okay, okay, okay.
Yeah,
Uh,
because I tried it. So in the changing aspect, I
yes,
use a string literal.
literal.
So it
It
worked. Yeah.
worked. Oh, awesome, awesome. Nice, nice, nice. Now you find out that that string literal. Uh, okay, but you have to make it mutable, right?
No, no, the main one is not
It's
mutable.
not
So
mutable.
is not mutable.
Okay.
So we are not supposed to add mutable in that declaration, which is the first one, Christian.
Okay.
Yeah.
Oh, sorry. Go and be opening code. Where
So
is?
can we just work on it now so that we all will see it?
Okay. What's that?
I said maybe we should just work on it now so that we all will see and learn.
Okay, 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 okay. Sure. So okay, I think this is it. So I think this is big enough, right? So let me undo. Okay. I just remember that I closed it. So we're like, we have our main function, and then we have another function called change name, right? Change name. So since we are using a string literal, so we have an str, and then of course, so here now we say we want the function to change anything given here, probably add to it. So we can say, okay, let's use hello world. Yeah, just a quick one. So we can say name, right? Okay, let's use first name and surname. So name dot push, is it push, wetin dey even dey call herself? Oh, I forgotten this method oh. No, not as byte, end to it. What did we use that time oh?
It was push you use now.
Oh, I'm surprised that I'm not seeing it here. So I think it's only for string this thing oh. It's only available for string. But let me check something.
Is it because you've not declared the variable yet or what?
No, it's not supposed to. I'm still surprised. It's not supposed to. Okay, let me see. The Rust can be crazy sometimes. Let me confirm. That means it's not available for string literal. So I think, which is quite understandable. Mm, it's not available for string literal. So how am I going to explain it? You know, I told you that by default, string literal is not the owner of the value. It's like borrowing it. Him too is borrowing it. Is not the owner. That's for string literal. So, but string now is the owner. So that's why there are some methods you can perform on string that you cannot perform on string literal. You understand? So that's why we are not seeing this push method in the string literal. So because even if we do and mute str, I think it's still the same thing. We will not get that push method. And even if we just decide to just use and string, you will not still get the push method. But how did you do yours? Or are you on your system? Probably you share your screen so that we'll see what you did.
Okay. Okay.
You're on your system, right? Johnson, are you on your system?
Yes, sir.
Okay, okay. So I think you can share your screen. Let me stop sharing mine. Beautiful.
So can you guys see my screen?
Okay. Uh, yes, we can.
Okay, so let me just. Okay, so let me just zoom
Okay.
in. So this is it. What we're trying to do, we
Yeah.
have a string,
Yeah.
right?
Yeah.
But me now I use V1. Maybe let me use name here. It's still the same thing.
Mm.
Name.
Still the same thing.
Then let's say new name.
Yeah. Oh.
And so we have the initial name here on
Yes.
string. So if we check it, we are going to have Rust, or let me change it to Christiana.
Okay.
Mm, So we are changing it to tally. So this second part now,
Mm.
we have a new declaration, which is moot, new name.
Mm.
So we are passing this guy. This is where our mistake was coming in. We're supposed to use a string literal here so that as this guy is coming in,
Mm.
we is going to be a string inside a string literal. So the string literal, we can convert it back to string. So
Okay.
because you said is acceptable by string literals and string
Yes.
also.
Yes.
So yeah. So what I did here now, I called back this new name now equals to tally.
Okay.
So if I do my cargo run, so this is it. The first
Mm.
one we have Christiana. So the
Christiana.
second one, and the new name we have
Mm.
tally. So even if we still check the first guy again,
Mm.
which is that name,
Mm.
it's still going to give us Christiana in this down part.
Good. So now, right? The
Yeah.
war. Okay. Yeah. This is a very good one. So
Yes, I'm hearing you.
okay. No, I want you to print it first so that we'll now analyze
So
it.
this is it name
Good.
Christiana. Yeah.
Good. So okay, I understand what you are saying now. We wanted to change. No, go back to the code. Don't worry.
Okay.
Yeah. Truly, we are attempting to change name, right?
Yeah.
So, but instead, so I think that's where the problem was coming from. But still, we're still supposed to be able to change name. So that was the
Oh,
goal, and the goal was to change a string.
yeah.
You understand? So
Yes.
to change a string, I think we have to now do what we did by borrowing the string as a mutable.
Yeah.
So I think the major problem we had was the fact that in the change string function we are passing it into, we are not using like borrowing it as a mutable.
Yeah. Yeah.
We're just passing s
Yeah.
instead of unmute s. So but this
Yeah.
also works actually.
Yeah.
This works.
Okay.
Yeah, it's a good one. I love this. It shows that you guys are understanding it. That's good. So write plenty rust to, like, plenty rust for you to really grasp and understand it. Like learning it alone, yes, you understand some things learning it, but then putting it to use, that's when you now, a lot of things will now start becoming more clearer and clearer and clearer. So any other question? Thank you for that, Johnson. So but hope you guys all understand what he's saying, or what he did. Okay, that's good. Emerson. All right. So I don't know. On Saturday, they say your dev hour is by 5, right? Okay. So let's see. I I hope I'll be able to make it that 5, so that we'll try and see how we can finish up everything. Because I think by next week, you guys will start having what are they calling it? Sion mentors.
Honestly, we would need you to be more around for us so that the learning can keep being more hands-on. We'll take your advice, we'll do as we instructed, we'll study and then we'll practice some more so that we, we get used to it because by the time those external mentors will come in,
Yeah.
it's just going to be a fire brigade approach from them.
Mm.
So would really love to drill down so that when they come, they'll find us solid and rooted in the beliefs.
All right. All right. No problem. No problem. So far is Rust, right? Even if like maybe okay, there's a concept that you guys see that this thing we need explanation. You can just tell Sir George, right? Sir George can shoot me a DM, or any of you can shoot me a DM. Yeah, I'm not the kind of official person. Yeah, I'm a normal person like you guys, so that we can find time, organize class, and then see how we can eat it together.
Thank you for that.
Yeah, no problem, no problem. So always remember, practice as much as you can. Go over the material. Okay, this one I did not make any additionals to the material. Yeah, I did not. So if possible, attempt this exercise you see on the last page, attempt it. So when next we meet, i will I will know how far that's you guys progress concerning it. If it's something that we'll do together, then we'll just go ahead and do it together. And if it's something that I see that okay, you guys are actually good to go, then I think we can just move on to the next thing. All right. So but hope Rust is not hard. mm. JavaScript is harder than Rust now, or what do you think?
I think so.
Yeah, actually JavaScript is harder than Rust.
JavaScript na headache.
Exactly. All right. So
I swear, mostly when it comes to API integration, fetching post and